Hello physical science students, and welcome to this video all about mirrors. In this video we're going to look at the different kinds of images that are formed in three different types of mirrors: plane mirrors, concave mirrors, and convex mirrors. First, mirrors form images by reflecting light rays. We know that when light is emitted from a light source, such as this flashlight, and it is reflected off of an object, the light travels from the object to your eye and you see the object. Light can also reflect more than once. It can reflect off an object into a mirror and then reflect into your eyes, but if there is no light available, you do not see anything. Now remember, we can think about light in two ways. We can think about light as a wave or a particle. We can think about light sources as sending out waves that travel in all directions, just like ripples on the surface of water spread out from the point of impact of the pebble. We could also think about light coming from the source as traveling in narrow beams like this, and then each narrow beam travels in a straight line, and we call those rays. Each one is a ray. Even though the light rays can change direction, your brain always interprets images as if light travels in a straight line. Let's take a look at the first type of mirror, a plane mirror. And in science, plane means flat. No elevations, no depressions. A plane mirror is a mirror that has a very flat, smooth surface, like the one this dog is looking into. So what do you see when you look into a plane mirror? Well, for one, your reflection is upright. You're not upside down when you look into a plane mirror. Also, this dog appears to be about maybe 25 centimeters away from the mirror, behind the mirror. The reflection of the dog appears to be about that same distance on the other side of the mirror. And if we were to scoot back, say, 2 meters, the reflection would appear to be 2 meters behind the mirror. So how can this dog see himself in the mirror? First, the light rays from a light source strike the dog, and every point that on this dog that is struck by light rays reflects those rays. So they travel in all directions back out. Let's say a light strikes his ear right here. It would travel back out in the different directions from the different directions that the light is hitting him. But for one, it would one of those rays would hit the mirror, and that would then be reflected off of the mirror and enter, well, you can't really see it very well, but the dog's eye right in here. And the dog sees himself in the mirror. If the dog's owner were sitting right here and looking at the dog, those reflected rays coming off of the dog would enter the owner's eyes and they would see the dog. But here we have the mirror placed in front of the dog. The light rays are reflected from the mirror and into the dog's eyes, and he sees himself in the mirror. So remember that your brain always interprets light rays as if they've traveled in a straight line. Your brain does not realize that the light rays have been reflected and that they can change direction. So that reflected image of the dog appears to be behind the mirror. We call that a virtual image. It's an image that is perceived by the brain even though no light rays actually pass through the location of the image. In this diagram right here, we have the dog, the real dog, the real image, and as the light rays are reflected off of the dog into the mirror in this direction, then they are reflected into someone's eye that might be looking at the dog. So this person would be able to see the image of the dog, and this line, no light rays pass behind the mirror. This gray line represents an imaginary light ray that is forming the virtual image, because no real light rays are actually hitting that image right there. This is another way to represent that with dashed lines forming those virtual rays. They don't really exist. No light is actually traveling along that path, but your brain is perceiving it that way. Plane mirrors always form upright, virtual images. Not all mirrors are flat. We can have concave and convex mirrors, and let's take a look at some of those. These are just examples of where you may have seen those types of mirrors before. A concave mirror is one in which the surface curves inward, like this. This is if this side were silvered for the mirror, this would be a concave mirror. There are several different features that you should know when we talk about concave mirrors. A concave mirror has what is called an optical axis. It is the imaginary line perpendicular to the mirror's surface right at its center. That is the optical axis. A concave mirror is also made so that when light rays are traveling toward the mirror parallel to that optical axis, they will reflect off of the mirror through a very particular point, and they all converge at that point. The light rays continue to travel afterwards. They continue to go on in a straight line, but they all pass through this point called the focal point. The focal point is always on the optical axis, and the distance between that focal point and the very center of the mirror is called the focal length. And we can use the focal point and the optical axis to diagram how some of the light rays that travel to a concave mirror are reflected and form images. We're going to draw a ray diagram for a concave mirror, and here is our object, a little candle that's upright. And remember that when light is reflected off of the concave mirror, it will travel through a focal point. So we know that light that is being reflected off of this object that is traveling parallel to our optical axis is going to travel through the focal point. So these are the first two rays that we draw. We'll call this ray 1 being reflected, ray 1. Now, just as light rays that are traveling toward the mirror parallel to the optical axis will travel through the focal point, light rays that travel through the focal point before hitting the mirror are reflected parallel to the optical axis. So we're going to draw a ray like that. This will be ray 2. We're going to have a ray that goes through the focal point, and it will be reflected parallel to the optical axis. Now the point where these two rays meet will be a point on that image. And this will be the image that is formed, and this is our original object. It will be that same point. We call this kind of image a real image because this image is formed when light rays converge to actual real light rays form to make this image. And that's what's happening here. Does a concave mirror always produce a real image? No, it does in this case, and we're going to look at what different types of images concave mirrors form. So let's look at the different kinds of images that are formed when the object is at different distances from the reflecting surface of the concave mirror. When the object is located way beyond the focal point, and that would be right here. Let's say this is our arrow as our object. And just as in our previous frame, this is producing a real inverted image. This image is diminished. It is smaller than the actual object. It's real, though, because light rays are really traveling through it. It's on this side of the mirror, but it's smaller. And this occurs anytime the object is beyond twice the focal length. So remember, this is our focal length right here, and 2 times the focal length would be right about here. And whenever the object is beyond that, we're going to get real and inverted for an image. However, if our object, here we have our pencil, and it is in between that point of the focal length and 2 times the focal length. Right here, this would be 2 times the focal length at that point. And when we place our object in between there, we get a real image, but it is magnified. When an object is located at the focal point, there is no image. This is really useful for spotlights because if we place a light source right at the focal point, all of that light will end up being reflected in a beam. Here we have a little drawing. It's supposed to look like a light bulb here right on the focal point, and it is sending out light toward that concave mirror. And remember that light traveling through the focal point will always be reflected off the concave mirror in rays that are parallel to the optical axis, and that is what's happening there, and you get beams. Car headlights, flashlights, spotlights, and other devices use concave mirrors like this to produce light beams that are nearly parallel rays. And last, if we place an object between the focal point and the mirror, we will see an image that is virtual and upright and magnified. So all those things come into play when the object is placed in this position. Shaving mirrors will do that, makeup mirrors that magnify very close-up objects. Now let's take a look at convex mirrors. And convex mirrors are mirrors where the surface curves outward. So where we had, this was our concave mirror, this is our convex mirror. And this is the mirrored surface here, it's curving outward. And you can see that as light strikes it, the rays are reflected in this manner. Convex mirrors always produce reduced, upright, virtual images. And you can see that here, they're going to produce a virtual image on the other side of that mirror, and it will always be upright, and it will always be reduced. Here's a little review for you. If you want to pause the video, make this little chart out and see if you can remember for the plane mirror, for the different situations in our concave mirror, and for the convex mirror, is the image virtual or real? Is the image inverted or upright? Inverted just means upside down. Upright is right side up. And what is the size of the image? Is it magnified? Is it bigger than the object? Or is it reduced, smaller than the object? So pause the video and see if you can fill that in. Here are the answers in review, and this just sums up everything we've looked at in the video. So if you want to pause the video, look at that, make sure you got your answers right and you understand what kinds of images are produced in each of these situations. That would be great. Here's some advanced ideas. Read through these, ask your own questions. Maybe you've got some other ideas of your own, and I look forward to seeing you in class.